classification is a theme. Hello guys, welcome to my channel. And if you are joining for the first time, it is Chemistry Simplified with Rosaline. In our previous video, we looked at the classification of the first 20 elements on the periodic table. But in today's video, we are going to be looking at the significance of the first 20 elements, the elements we classified on the periodic table. The vertical columns are called the groups, while the horizontal rows are called the periods. Let's take a look. These are the vertical columns. These are the vertical columns we see on the board, and we call them groups. While the horizontal rows, these are the horizontal rows, we call them the periods. And on the periodic table, we have 8 groups. Let's count, meaning we have 8 vertical columns. We are counting together. 1, 2, 3, 4, 5, 6, 7, and 8, signifying 8 groups on the periodic table. I want us to take a closer look at the table. In between group 2 and group 3, there is another column here. Here, elements that are placed here are called the transition elements. That will be a topic for another day. Now, let's continue. Let's look at the numbering of the groups. Groups are numbered using Roman numerals. These are the Roman numerals from group 1 to group 8. We number them using Roman numerals. Let's take note, because we'll go to period. We are going to be looking at a different numbering. Now, let's continue. What then is the significance of all these groups we see here? The significance of all these groups is number of electrons, number of valence electrons to be precise, number of valence electrons. When we talk of number of valence electrons, what do we mean? We mean the number of electrons that are found on the outermost shell of each of these elements. Meaning an element like boron has an outermost shell, and there are electrons allocated to that outermost shell. The last shell precisely carries the valence electrons. So, for instance, elements in group 1, they have 1 valence electron. Elements in group 2, they have 2 valence electrons. Elements in group 3, they have 3 valence electrons. And it goes same right to elements in group 8. Now, let's go to periods. Periods are the horizontal rows. These are the periods. The horizontal rows, this way, these are the horizontal rows, and they represent period. On the periodic table, we have 7 periods, meaning we have 7 horizontal rows. But when we look at the table, we have the periodic table we have on the board, we have just 4 periods here. Why? Because we are basing our study just on the first 20 elements of the periodic table. But when we are looking at the enlarged periodic table, the macro periodic table, there are 7 periods. As like I said, we have 4 here because we are dealing just with the first 20 elements of the periodic table. What then is the significance of the period? The period signifies number of shells. The period signifies number of shells. For instance, elements in period 1, they have 1 shell. Elements in period 2, they have 2 shells. Elements in period 3, they have 3 shells. Elements in period 4, they have 4 shells. Right up to elements in period 7 with 7 shells. Let's look at the numbering of the period. Like I said, when we are talking about the groups are numbered using Roman numerals. Now, periods are numbered using Arabic numerals, just like serial numbers, like you can see on the board. Periods are numbered using Arabic numerals. Now, we have seen some numbers here on the board. From 1 to 20, they also look like serial numbers. From 1 to 20, they also look like serial numbers. But in chemistry, we don't call them serial numbers. We call them atomic numbers. On the periodic table, elements are classified in order of increasing atomic number. Why? Because the properties of all of these elements, the elements we see here, they have chemical and physical properties. And the properties of all of these elements we see on the board, they are greatly related to their atomic number. This leads to the modern periodic law, which states that the properties of elements are a periodic function of their atomic number.